Now let's look at some examples that apply all of the ideas from the first video. So this first example, given this diagram, find the radius and the exact circumference. So if we think about this picture, what do we know? Well, there is a beautiful right triangle where the hypotenuse of that right triangle is the diameter. And so Pythagorean theorem is in play, and so I know that b squared is equal to 12 squared plus 10 squared. Work that out. D squared is equal to 144 plus 100. D squared is equal to 244. The diameter is the square root of 244, which is approximately 15.6. My question asks for radius. Remember, the diameter is equal to 2 times the radius. So if I divide the diameter in half, I find out that my radius is 7.8 units. Now I've done all this work. The exact circumference, you could, exact means leave pi in the answer. Pi functions a lot like a variable. And so we create a lot of rounding error when we multiply by 3.14, and so sometimes it's better to not. And so our circumference is 15.6 pi units. Because it is like perimeter, it's just units. So when we get down here and we start looking at arc measure. So arc measure, remember, is the exact when it's a central angle. The arc measure is the same size as the angle, the central angle. So for example, this central angle right here is 90. So this arc right here is 90. This central angle is 25. And so this arc right here is 25. Now, if we think about this entire piece, that's 180, or even better, if we look just at this side right here, that has to be 90. So this arc right here is 90 minus 25, and so that arc right there is 65. Well, this angle is 65 by vertical angles, so is this angle and this arc. And if we look at then this angle or this arc, both of these together have to be 180. 180 minus 65 is 115. And so this arc is 115. So everything I could possibly want to know, I've marked on my picture. So then when I come back, and I'm just going to grab a highlighter, I want the mark of AC, the measure of A to C. It's a parts to whole problem. And so when I add 25 plus 90, that arc is 115 degrees. If I look at the arc AE, A to E, I calculate that already to be the same as its central angle, and so that arc is 65 degrees. If I want to look at the measure of arc, now here comes a major arc, A through E to C, I can either add up each of these individual arcs or subtract those two from 360 because it's all the way around is 360. And so the measure of this arc is 65 plus 115 plus 65, and so that arc ends up being 245, sorry, 245. You also could have seen or shortcutted that these two together are 180 plus 65. So lots of different ways to see how to get the answers.